Hello students, we are going to discuss the chapter motion. Let's start with the topic, what is motion? So to understand the motion, the first thing come to our mind is the movement of a body. If a body is moving, it means that the body is in motion. But to be more specific, we can say whenever a body position changes with respect to time, with the passing of time, the body changes its position, we can say the body is in motion. Then another way of saying it, like a body is said to be in a state of motion when its position changes continuously with respect to an object taken as a reference point. So that's very important. Whenever we have to describe whether any body is in motion or not, it is possible only when you define a reference point. To defining a reference point, then only we can say a body is in a state of motion or in a state of rest. So let's see this in example. Here, the body was at position A at any point of time. And then we can see the body reaches the another position B. Or let it be a car was at position A. Now the car is at position B after a time T. So we can say that the position of a car changes with respect to a tree, or the position of a car changes with respect to a house. Hence, we can say the car is in a state of motion. In a similar way, let's see how we can define the state of rest. So if a position of an object is stationary relative to another object with a passage of time, then we can say that that body is in a state of rest. So if we say that in an example, the house is in a state of rest with respect to a tree, it means the position of a house is stationary with respect to a tree with the passage of time. So this is how we can define the position of a state of motion and a state of rest. Now, sometimes it happens a same body can be in a state of motion. It can also be in a state of rest. So if the reference point changes, so we can see here the body or a person A, he is a person B and he is a person C. So the person A can be said to be in a state of rest with respect to a person B. Why? Because both person A and B are standing on a car and the car is moving with a certain velocity. So it means that the position of A with respect to B is that is fixed, that is not changing. But if I compare the position of A with respect to a C that is standing outside the car, then we can say that position of a person A is changing with respect to C. Hence, the person A is in a state of motion with respect to C. So at the same point of time, person A is also in a state of motion and he is also in a state of rest if I change the reference point. So whenever we describe any body is in a state of motion or in a state of rest, it is then equally important to define whether what is the reference point. Because in actual sense, we are all on the earth and earth actually it is rotating. So if the earth is rotating, it means that each and every object which is on the earth, that is in a state of motion actually. But if I define the with respect to earth, then we can say whether body is in a motion with respect to earth or not. Now we are going to discuss about the difference between a distance traveled and the displacement. So here we are going to consider the 2 points. One is a point A, another is a point B. This is our initial point. So the point A, from where we have started, that is our initial point. And point B, where we have finally reached, is our final point. So if I started with the point A, suppose I go to some shop, then I go to one of the friend's house, and then finally I reaches the school. So this is the actual path which I have followed to the shop, then to a friend's house, and then to the school. So our distance traveled would be always the actual path which you have followed. The actual path which you have covered, that is your distance covered. But what is the displacement? For a displacement, you must have the initial point and the final point. And the shortest distance between the initial and the final point, that is known as the displacement. So how to achieve the shortest distance? If you connect the initial point and final point by a straight line, that would be always the shortest distance. So this is what is shown here, the shortest distance between the initial and the final point, and this is your displacement. So the displacement is not depending on the actual path what you have followed. It is only seeing what is your initial point from where you have started and what is the final point where you have reached. You have to see what is the shortest distance between them. That is your displacement. Another thing here, what we will see is that distance does not have any direction. We will only say that from the starting to the end, how much distance you have covered, whatever actual path you have followed. So how much distance you have covered. But for a displacement, we have to see the direction also. Okay. And the direction of the displacement is always from the initial point towards the final point. So here, if I see the direction, so the direction of the displacement would be from the initial point to the final point. So this is how we can get the direction as well as the value of a displacement. Now let's move to the next part, the physical quantity. So the term which I've seen, the distance, the displacement, all these are a physical quantity. How we can define a physical quantity? The quantities which can be measured are known as physical quantities. For example, the distance, displacement, speed, velocity, volume, mass, time, all that we can calculate in a definite value. It means these are the physical quantities. If I say I like you very much, so if I like you very much, this cannot be measured. So it is not a physical quantity. Okay. Now the physical quantities can be of two types, the scalar as well as vector quantities.